Hello, my YouTube 3D printing followers. Thank you for watching my newest episode of making functional 3D printed parts. You can see in the video alongside me the flagpole with printed swivel mounts that is currently flying our home's United States flag. This is the latest version of quite a few predecessor attempts, and it's not flawless, as the flag does sometimes wrap around the pole in the wind, but otherwise it works. You, my dedicated followers, get a kick out of following the steps that I take in the process, so here goes. First, there was the simple flat donut type mount that resembles and replaces that which came with the original flagpole, but over the years it wore out, finally breaking. I use Autodesk Fusion 360 as it is my preferred design software, and I made a simple 7-cent replacement part. So here is the flagpole swivel finished. As you can see, it is a very flat shape, but round to go around the flagpole. We'll come over here to the first step of the design process, which is to come up with a sketch. You can see I just took a couple of these circles, center diameter tool. I created a couple of 3 circles. I made a protrusion out of part of the outer circle that is made up of a couple of about 3 straight lines and then some rounded curves for the few of the edges. Okay, that's that. Finish the sketch. Now we'll go to the next step, which was just to give it some height. That sketch was pulled up to a distance of 2.5 millimeter thickness. Click that OK. You can see how it's very thin, but you can see these sharp edges won't do. So the next step, clicking the edit feature for the, and going to the third step, giving these fillets, all 20 of them here, a measurement of 0.75 millimeters. And that's it. The second version here is a little bit more complex. It has 2 parts that are printed together. This part swivels around a larger inner part right here. So I call this the inner ring, and then the outer locking coupling that would screw onto the flagpole. So after taking some measurements, this is the finished version. We'll just flip through all of these stages. First, I created a similar design, similar to the last one, for the swiveling inner outer ring. Now we'll go on to taking a look at, this was simply adding some circles and refining the sketch. Now we give it some mass, probably the same amount. Let's take a look at that to see how big it was in this version. So it's a 2.3 millimeter distance. We'll click cancel. Moving on, we make more sketches. This would obviously be for the inner section that touches the pole. Moving on, after finishing that sketch, moving on, giving the inner piece some mass as well. Okay, this part was creating a second surface on which to do a new sketch so that there would be a area that was actually thicker that would hold this ring from slipping off the end. Finish that. Again, we're making another sketch so that we can make a different diameter circular sketch. Giving that new increased diameter some mass as well. And next we'll have to do the same on the other side to lock that swiveling ring in. So we'll move on there. Now we're looking at the bottom, adding another distance here. Finish sketch. We're going to give that some mass. So now we do have two locking thickened areas around the flagpole fastener. Take a look at these chamfers, which get rid of some of that. There's more chamfers being added here. I wanted to do it in several stages. More chamfers. Finally, putting a hole in the side so that we can drill, actually screw a screw through this outer component and into the wooden flagpole itself. And finally giving that some, oh, and by the way, I specified these types of holes to this feature so that it was countersunk. And finally, the last segment giving that chamfer. So that was the entire process. Unfortunately, this turned out to be a little bit too small. You can see that this little thin component here, even though it swivels just fine, may not stand up to the weather over the time, the sun beating down on it, hot, cold, so flag pulling on it, and eventually I'm sure it would have broken. So that was a good attempt for the next phase, which we'll take a look at that now. Looking at now is the final version, version 4. And you can see that this rotating, sliding, swiveling piece here is quite a bit thicker than this last version that we just looked at over here that just had this thin flip back and forth. And this is the version that was used. We won't worry about going through all these steps. They're nearly identical. Thanks for watching. To make a 3D printed swiveling flagpole attachment part where the parts are printed together